So today you're reviewing how to factor polynomials. So for this first one here, this is a binomial because you just have two terms here. And remember, you should, like, no matter what it is, you should always be checking to see if there's a GCF you can factor out first. So for this one here, so you know there's a GCF you can factor out because you have 8 and 12. And you know 4 would be the biggest number that will go into both of those. And for the variables, so you'll take out the greatest number of x's that you can take from both there. So you'll take x to the third. So you can go ahead and factor out a 4x to the third to start. And then you're just filling in your parentheses after this. Because if you're not 4x to the third times what will give you the 8x to the fourth? So 4 times 2 will give you the 8. And then you want x to the fourth, and you have x to the third there. So that'd have to be 2x then. And then you'll figure out 4x to the third times what will give you the negative 12x to the third. So then that'd be negative 3. And then for these after that, you can always check to make sure there's nothing else you can do with what's inside your parentheses there. And you just have the 2x minus 3. So it's not a difference of squares there, and there's nothing else you can factor out the inside. So that's your final answer there then. And then for this next one here, for the GCF with the trinomial here, so you'll actually start off the same way as this one here. You just happen to have 3 terms. So you're always checking for the GCF first. So for this, you have 8, 12, and then 6. So your number GCF will be 2 there, since that would be the greatest number that will go into each of those 3 terms. And then, so you know you can factor out a 2. And then for the variables, you have an x to the fourth, an x to the third, and then an x. So the most x's you could take out would just be a regular x with a 2. So you can factor out a 2x here then. And then you'll figure out 2x times what will give you the 8x to the fourth. So 2 times 4 will give you the 8, and then you want x to the fourth. And you have an x so far, so that'd have to be x to the third. And then you're figuring out 2x times what gives you the negative 12x cubed. So that have to be negative 6. And you want x to the third, and you should have an x so far. So you'll need 2 extra x's with the negative 6 then. So x squared then. And then you're figuring out 2x times what will give you the plus 6x there. So that'd be plus 3 then for the last term then. And then once you do that, you can always check inside there to see if there's anything else you can do. So there's not a number or a variable you can factor out from these 3 terms inside there. And then this, you can't do a times c here, like you can't do 3 times 4 because this is not in your regular trinomial form. Plus this is to the third, and that's squared, and that doesn't have an x at all. So there's nothing else you can do there. So you'll just stop there with your final answer. And then for the trinomial ones, so you're always check for a GCF first as well. For this next one here, so you have x squared minus 8x minus 20. So there's no GCF you can factor out from these 3. And so you can, since there's not a GCF you can factor out, you can just do a times c first. So negative 20 times 1. So that'll give you negative 20. So here you're looking for factors of negative 20 that would add to be the negative 8. So for this one here, you're trying to multiply to get a negative number. So you'll have to have a positive and a negative there. So you can just go ahead and make a list of the factors then. So, you know, you need one of each. So you can write 1 and 20 first. So you can just make each of them negative to start. And then the next factor of negative 20 would be 2 and 10. So you can write the 2 and negative 10, and then negative 2 and 10. And then your last factor, negative 20, would be negative 4 and 5 there. And then you're figuring out which of these would add to be the negative 8. So it'll be the negative 10 and the 2 then. And then after that, so you could sub them in if you wanted to here and do it the long way, although since the coefficient of your x squared term is 1, you can just go ahead and use the shortcut way in the end. So pretty much you can just sub in your factors here as your answer. So since you have a positive 2 here, you know one of your final factors will be x plus 2, and then your other one will be x minus 10. You can just sub them right in there. And you know you can do that since the coefficient here is a 1 in front of your x squared term. And you could also do it the long way and sub them in and then factor by grouping, but you'll get the same thing either way there. And then for this next one here, so you can start off the same way. So you can check to see if there's a GCF you can factor out from these three terms, and there's nothing else you can factor out from those three terms. So you can just do A times C to start. So 2 times 3, so that'd be 6. So here, so you'll need sorry, this is supposed to be a 6. So you'll need factors of 6, that would add to give you the -7 there then. And so, like some of the ones you get done before, so you'll need, so 2 positives would multiply you a +6 or 2 negatives, but 2 positives wouldn't add to the -7 there, so you would have to have 2 negatives. And you can just make your list of factors of the negatives, or of the 6, sorry. So you'll have -1 and -6, and then -2 and -3 are the only set of factors there. So you can figure out which of those would add to the -7. So the -7, so it's be -1, -6. And then after that, so you can sub your factors in next. So you know your 2x squared will stay, and then you can rewrite your -7x as -1x and then -6x. So it would look like this when you sub in. So you can keep your 2x squared and then your +3, and then you expanded the -7x as -1x minus 6x. And then remember from here, you can group your first two terms and then your last two terms. So 2x squared minus 1x, your number GCF for those two will be 1, because that's the greatest number that would go into both of those. And then you can also take an x with it. So you can just factor out a 1x from those two to start. And then you can fill in your parentheses. So if you're figuring out 1x times what would give you the 2x squared. So that would have to be 2x, would give you the 2x squared there. And then x times what would give you the -1x. So that'd be -1. And then you can group your last two terms there. So you're figuring out the GCF for the -6x plus 3. So for this one here, your GCF for these two will be a -3, because you want to switch the signs. That way it matches your other set of parentheses then. So you can factor out the -3. And then -3 times 2x will give you the -6x. And then -3 times -1 will give you the +3 there like you want. Plus remember, these parentheses have to match each other. So both of them do match, since they both have 2x minus 1. And then you can write your answer this short way here. So you'll have x minus 3 and then 2x minus 1 as your other factor when you bring both of them down. So that'd be your answer then. And then for the next one here, so for this one here, so when you check to see if there's a GCF to factor on this next one, so there is going to be a GCF here. So if you look here, so 2x squared plus 10x plus 8, so your GCF here will be a 2. So you can go ahead and factor out a 2 from all those then. And then after you factor out the 2, so then you can do a times c. So you're ignoring the 4 till the very end. You're ignoring the 2 till the very end, so you'll do 4 times 1. So you'll need factors of 4 that add to get the 5. So you need factors of 4 here, so you'll need 2 positive factors. So you can make your list there. So, and they'll have to both be positives. So 1 and 4 would be the first one, and then 2 and 2 are the only set. And then you're figuring out which of those would add to be the 5. So it'll be the 1 and 4 that you can sub in then. And then after that there, so you can actually go ahead and use the shortcut way in the end here, because your coefficient of your x squared term is 1, because your 2 will be out front here, because you can't forget it. And then one of these is +1 and one is +4. So one of your final factors will be x plus 1, and then the other will be x plus 4. So it looked like that then for your answer. Or you could also do the long way. This is just a little easier. And you can only do this if the coefficient's 1 of the x squared term. And then for the next one here, so when you check for a GCF, so there will be a GCF you can factor out on this one. So 6x squared plus 10x plus 4, so your GCF will be a 2 that you can go ahead and factor out from all those to start then. So pretty much you're just dividing all those by 2 to start to make it smaller and easier. And then you can ignore the 2 till the end, so you'll do a times c, so 2 times 3. So here you'll need factors of 6 that add to give you the 5 then. Hold on, this should say 6. Okay. And then you're going to need 2 positive factors here, so you can make your list. So you'll just have 1 and 6, and then 2 and 3 in your list then. And then you're figuring out the pair that would add to give you the positive 5. So it'll be the 2 and the 3 there. So you can sub in those 2 then. And then for this one here, so you can't use the shortcut way like we used here. So you'll have to sub them in the long way. So you can ignore the 2 till the very end, and you're just subbing in the 2x plus the 3x for the 5x on the middle there. So it would look like this, because your 3x squared would stay, and then your 2 would stay, but you're writing out 5x the long way there. And then you're grouping the first 2 and the last 2. So for 3x squared plus 2x, so 3 and 2, your number GCF would be 1 there. But you could take an x from both of those 2 terms. So you can go ahead and factor out an x there. So you can write x and then start your parentheses. And then you're figuring out x times what will give you the 3x squared. So that'd be 3x. And then x times what will give you the 2x. So that'll have to be plus 2 there. And then your GCF for the last 2 terms here, this will be you have 3x plus 2. So the GCF here would be 1. So you write plus 1, and then you can fill in your parentheses. So 1 times what will give you the 3x. So that'd be 3x, and then 1 times what will give you the 2. So that'd be plus 2. And then these match like you want them. So then you can write this the short way. So you'll have x plus 1 as one of your factors, 3x plus 2, you'll bring one of those down, and then the 2 out front that you should put back on. So that'd be your factored form in that end there. And then for these here, so these are the ones you learned about yesterday. So for the difference of squares, remember this will work as long as both of your terms are perfect squares and they're subtracting. So for this one here, you should check to make sure both these are perfect squares to start. And also you should check to make sure there's nothing you can factor out first. So for this one here, there's nothing else you can factor out from the x squared minus 49. So you can just go ahead and check to see if it's a difference of squares. So x squared is a perfect square, and then 49 is. And remember, for the difference of squares, that's where your parentheses match, except one will have a plus and one will have a minus. So one of these will be x plus 7, and then your other one will be x minus 7. And it doesn't really matter which comes first there. And then for the next one here, so this one you'll probably notice both of these 2 terms are perfect squares, but you have to factor out your GCF first, because that's always the first thing you should do here. So you're figuring out the greatest number that will go into both of these 2 terms. So 4h squared minus 36. So you can factor out a 4 from both of those, and that's what you have to do to start here. You can't just jump ahead and do the difference of squares stuff, just because you should go ahead and take out the GCF to start, because you should make sure that you factored out everything that you can. So you can factor out a 4 from those 2 to start. So it'd look like this. And then from here, so then these are perfect squares, so then you can actually write your difference of squares there. So you'll still have your 4 on the outside, and then remember, the square root of h squared is h, and the square root of the 9 is 3. So the 4 is outside, and then one of them be h plus 3, and then your other one be h minus 3. So just make sure that you're always factoring on the GCF first. So with the 2 terms here, so sometimes the 2 terms, it'll be a difference of squares. Although sometimes with the 2 terms, the only thing you can do is factor out a GCF like this one here. So you're not really going to know for sure, but if you factor out a GCF first, then you can check to see if it's a difference of squares. So for the 2 terms, don't necessarily think that it'll always be a difference of squares, because sometimes the only thing you could do would be to take out a GCF there. Okay, so that's the last one here. There's a Google Doc that you're going to work on, which is a mix of all these problems here. Just let me know if you get stuck on it though, and I can certainly help you.